first from the panelists. Anyone wishes to ask a question? We have two questions from the audience as well.
Eric, I think well, number one is a terrific talk. I always learn stuff when you talk. So I appreciate that. The CAM-K2 stuff is really, I think, quite striking. This idea that you can make a cell more fit after editing. I mean, where do you see that? Where do you see that going in terms of, all sorts of different diseases, really?
Yeah, I think it's a really fascinating question. So we have thought, as you won't be surprised to learn, that we've thought hard about critical post-translational modifications of target proteins, some of which are in your favorite pathway.
Yeah, I'm sure.
And can we inactivate the pathogenic activation by modulating single amino acids? And I think there's a lot of opportunity for this. It won't work, of course, in every case, but I would encourage people, if they have a really well-defined phosphorylation site or other post-translational modification, if it lends itself to base editing, it may be a way to selectively inactivate that pathway. So yeah, it's a new concept, and we'll see where it goes.
Fantastic. Mike.
Yeah, Eric, brilliant talk. As always, really enjoyed that. Your image, your AI-generated picture at the beginning of your talk made me wonder. In your therapeutic slide, you talked about looking at the many targets that are out there for myopathies, in titin and myosin and troponins and various factors. Do you think using machine learning or AI may be the way to start prioritizing those and to develop those strategies relatively quickly, rather than sort of doing them one at a time? Is there a way, have we learned enough to start to figure out how to do these en masse?
It's a really good question. I think we're getting there, but we're not really there yet. So you can identify targets for editing, base editing, or prime editing, or other forms of editing. But really, we don't have a way yet, at least that I'm aware of, to predict with absolute precision how efficiently a particular site will be edited in a particular context. So I do think that, at least for now, it's essential to experimentally validate these targets. But will AI ultimately accelerate this and maybe bypass some of the experimental hurdles? I do believe it will. So yes.
Thank you.
Very good. Excellent. Eric, do you have access to QA on your screen? If not,
yes, I can see that. Let's see. Okay, I've got a question here. Should I just read them, or how do you want me to do this?
RBM20 editing was used to treat dilated cardiomyopathy. What is the expected level of RBM20 in mice or other models after 12 months and 15 months, for example? What type of immune response could be anticipated?
Yeah, so thank you for that question. The edited mice that we've created in our lab, as far as I'm aware, they have a normal lifespan. We've not seen any decline in those mice at late stages. Immune response is an issue that I alluded to that really needs to be, I think, carefully considered in human translation. We have not seen immune responses in mice to gene editing components, and our most extensive work on that topic has been in the correction of Duchenne mutations, in which we've carried out mice for their entire lifespan in the absence of immunosuppression, and we've not seen immune responses. But I do feel strongly that if gene editing is going to be taken into the human setting, that it will be important to combine it with immune suppression, as is the case with virtually all gene therapy approaches when one is introducing a foreign gene into a patient. But those are studies that will need to be pursued rigorously.
Eric Small has a question for us.
Yeah, sure. Thanks. Fantastic talk, Eric. It's great to see you again. I was really interested in the PHF7 story at the end and wondering, you found this in a screen. Is this part of sort of the endogenous cardiomyocyte differentiation program in the embryo? And do you have any insight into the mechanism as far as is E3 ligase activity important for its function?
Really good questions. As I alluded to, PHF7 is expressed in MESP1 positive progenitor cells that are also marked by expression of GATA. Whether it plays a role there, I don't know. You won't be surprised to know that we've made knockout mice, and there's also a PHF7 related gene that we're working on. So I don't really, I don't yet know the answer to that question. And can you please repeat your second question?
Do you know if the E3 ligase activity of this?
Oh, yeah.
Important?
I don't know the answer to that. I think Glynis Geary is making mutations of that, and I'm not aware of the results of those experiments, but I suspect the histone binding activity is going to be critical to its function. Whether the E3 ligase activity contributes or has some other role in this, I don't yet know.
So Eric Olson has a question for Eric Small. And the question is, did you drink all those champagnes by yourself? It's behind him. Did you see the bottles? Robert Shorts has a question for you. Robert Shorts wishes to know, does your reprogramming factors block myocyte apoptosis?
Hey, Bob, really good to hear from you.
Where is he? To activate him.
I don't know the answer to that, Bob. I think that's a good question. And as the PHF7 in vivo work that I described at the end is all underway, and I just put that out there to some food for thought for people. I do think that blockade to apoptosis may contribute to the salutary effects of PHF7 in vivo, but we're still looking into that.
Very good. And final question from DeLong, and wishes to know how to increase expression of sgRNA, guide RNA, and also when duplicating the guide RNA sequence in the plasmid, how to overcome the difficulty of synthesizing a long duplicate sequence.
Okay, well, let me touch on the first question first. So your question is a really good one, and that is, and it was a big surprise to me when we first got into this. The question really is, at least that I had, is what are the limitations to the efficiency of editing? Is it the editor or is it the guide RNA? And turns out it's the guide RNA is limiting. So strategies that can enhance guide RNA expression also enhance the efficiency of editing. So I think whether there are better ways, I'm sure there are better ways to deliver the guide RNA through more active Pol3 promoters, through multiple expression cassettes. We used 3 different expression cassettes for the guide RNA in our Duchenne work. Or whether the guide RNAs can be delivered in an alternative approach, perhaps through lipid nanoparticles themselves, and maybe that would enhance editing. I think those are really important questions that will need to be addressed. And your second question deals with the technology of the sgRNA cassette, and I'll simply say that I think there's a lot of room for improvement there, and I think there's probably many ways to improve it, and hopefully we and or others can solve that challenge.